Hi, I'm GUO CHENG GUANG, 12 years old, secondary one from NUS High School. Right now here, we're still continuing with our ordinary differential equations. Well, in ordinary differential equations, those lessons that we had before are about operators and comparison of coefficients. But right now here, we're having a little bit something else. We will need to know these parts before we can just sort of move on with the others. But right now here, what we are having right now here, well, first part, y. Well, y, of course, in those ordinary differential equations, we have y as a function of x. So that's a function of x. Then, of course, first the derivative. Sometimes we do have to find that. Well, it's actually all. Then for the first derivative, you might just write it as this form. You may write it like that, f prime then x. But if you have realized that when we try to find it out, it is actually another function of x. So we can use it as another function of x. Like, for example, just use gx. But this part, y prime, it is representing dy dx. Okay, so it represents dy dx. That means you differentiate y with respect to x. So in this part, you have y with respect to x. Then, wait, what if the question asks dx, dy? What if it is like this? Then the first thing that you have, wait, what if I just reciprocal that I get 1 over dy over dx? Now that I sub in the result here, which you can just use it as y prime. So for the first derivative, maybe that easy, you just flip this to the denominator of the denominator. This part is still easy. What if I ask, because that is the first derivative, then the next step is the second derivative. This second derivative, what can it be? So how do I find it? How do I find the second derivative? Is it like, well, you just differentiate this with respect to y again? Oh wait, y prime, this is with respect to x. If you change it to y prime prime, that will be differentiate 2 times, but with respect to x. Now that is with respect to x, but we want with respect to y. So that means you can't have just simply in the denominator that part. So we do have to think of some other methods that we can use to solve this. So let's first think about this second derivative. In this second derivative, can we find a way to just split them up? Well, not actually splitting them into 2 different parts. But we can write it like this, and when we write it like this, so it is basically saying we differentiate, we find out this part first, after you differentiate again. Yes, you can write it like that. But how does that help? Well, there's a little bit of trick here. So you have these 2 parts. This is the differentiation. But wait, what if I times something that is also something about it? The dx. So this part doesn't affect it because you can just say they simplify, they get 1. So that doesn't affect it. Then you just write back the rest of the parts. So this part is about differentiation. This part is what you times in the extra. These 2, they are multiplying. These 2, they times each other. So that means we can change the order since they're not it's one differentiation of the other. So that means these 2 can change positions of any of them. We can change positions of any. If we change these 2, Well, that means it is this part you differentiate here. Well, because it's here with the d. But what if we just change these two? Which actually is something similar to that. So what you get is dx, dy. Since you change these two parts, then you have dx. Here dx, dy. But you don't think about simplifying them because at this part, we purposely times that part here. So that means we just need to figure out this part behind this part of the differentiation. And this part is what we can use from the front. Like this. Then, so this part, it is now differentiating with respect to x. So that will be much simpler. So basically, you're just differentiating this part. Okay, you differentiate this part 1 over y prime. So y prime is, in this part, is to the power of -1. -1. So that means you need to be aware of a negative. Then 1. So when you differentiate, you get 2. Basically square. Then let's just change the type of this bracket. And this part. Then the numerator, beware, this part, it is to the power -1. Then you have to be careful of that there is a chain rule. There is this chain rule. So in this part of the chain rule, you differentiate y prime. So you get y prime prime. That's what you get after the chain rule. Then after that, you just put these two parts together. And this is what you get. So this part still seems simple until the second derivative. Then how about the third derivative? Now, it may seem more complicated and more complicated. But wait, what if we just try out this method again? Because of course you can't just like straight away differentiate that with respect to x. With respect to y. So let's try this method again. So this method over here, that means we just think that we just separate them. We just think about separating these. Then after that, we actually times something just to make it. So just a dx and dx. So dx over dy. Then still dx. After that, this part behind. And wait, what you'll get from this part is something similar, but that makes it able to solve. So that means you just have to change this part into differentiating with respect to x, then it will be much more simpler if you change it like this. After that, at this part, you change it into with respect to x. The front part, of course, you can still use that part. It's just like you're allowed to use both of these solutions after that. So you can have first this part, then in the next two parts, you solve them together. So at this part, dx, then this part behind, we use this. So that means it is negative y, second derivative, then it's like this. So this is what you have. So next, this negative, of course, you can just put it all the way in front first. So you get negative 1 over y prime. So from this part behind, y second derivative, y first derivative to the power of negative 3. Of course, you both need to differentiate. You both need to differentiate. But if we use, okay, at this part, we do have two methods. One method is using the quotient rule. But quotient rule, you differentiate this part times, after that you minus, differentiate this part times, after that below square. Wait, isn't that very complicated? Why not we use something more simpler? We use the product rule. So product rule, we're using -3 here. So -3. Then below here will be to the power of 4, since change. Then y second derivative. So y second, wait, this is not to the power of 11. Second derivative. Here you already have one. Then below here, you differentiate it and you get another, since it is with respect to x. So yes, you'll get another, so you get the square of y second derivative. This is for the first part. You're differentiating this part with respect to x. Beware the product rule, so you need this part too. So for this part above, beware we took out the negative already. This negative is only because from this part you have to the power of -3. So here is most likely add. Then y second derivative, you just differentiate that directly. You don't have any others. So that means here will be a third derivative. And at this denominator, there's no change. So that's what you have. So at this part, we can times them in already. We can common denominator at the same time. So if it's just within these two, that will be to the power of, which is first the derivative of y to the power of 4. Since you times this extra outside, you get to the power of 5. So this first part is a positive 3. Therefore, the second part is a negative. So negative, since you missed out on one of the y prime, so you times y prime there. So you get something like this. So this, you can write that dot as to represent times together. You also can choose not to write that dot. So in this third derivative, this is what we have. So if you have realized that we're actually using this method just to find out one after another, just continuously like that. We already have until the third derivative. How about the fourth derivative? So right now here, we have first derivative, we have second derivative, we also have our third derivative. How about we just have one more, which is the fourth derivative. So in the fourth derivative, at this part, we're just going to use a similar method to that. And we have to separate from these. Okay, so this fourth derivative over here, let's check. So we have dy, then after that is the third derivative, or you can just straight away write it as this part, dx, then dy. Then behind here, dx. And after this part, you have third derivative, which this solution to the third derivative, you can straight away use this part. Okay, so you can straight away use that part. From the first part, you also can use this. So here you have 1 over y first derivative, then at this part. So this is what you're going to have. Then that means you'll need to differentiate this whole part, but wait, this whole part. We're still going to use the product rule here. Since the quotient rule will just differentiate this part, it'll seem like very complicated. So at this part, product rule, we can have this numerator we can differentiate the numerator first. So differentiating the numerator. Differentiate the numerator, so we get 3, then 2 times, so that means it's 6. After that is y second derivative. After that, y second derivative, you differentiate it again. Then you get y third derivative. Then behind here, you subtract. Y first derivative will become y second derivative. So at this point, you're using something like, well, actually you're just using the product rule again. Like this for the first part. Then after that, denominator, you'll say the same. So this is for the first part of the product rule. Then after that, at this part, we're going for the second part of the product rule. So for the second part of the product rule, that means we're differentiating this denominator. So we're going to differentiate this denominator. That means here is actually to the power negative 5. So that means you have a negative 5 out here. Then after that, okay, let me just write the same first, okay? And then after that, we'll see about what kind of changes will there be. So this 5, that means it will become to the power 6. But 6 inside here, y first derivative, you differentiate again. That means you get extra y second derivative, then you times them all up here. So here it becomes cube, then behind here, well, you can just rearrange them again. So then you get second derivative. After that here will be third. So you have something like this. Then after that, from this part, 1 over y prime, yes, you can times it in. So that means in total there will be to the power of 7 at this part. So this is to the power of 7. Then here you need to times an extra y prime. Here you have 5, then second derivative, then third derivative. So then it's times the extra first derivative. 5, 1, 2, 3. That's what we have for the first part over here. Then for the second part there, it is this part square. Like this. Then after is this part behind, so you get minus 15. Then y second derivative cube. Then behind there you have plus 5, y first derivative, second derivative, and third derivative. But wait, after that we realize these two parts are the same, so we can at the same time just straight away combine them into 10 of these. Okay, so this will be for our fourth derivative. So yeah, that's what we'll have for this fourth derivative over here. Okay, so I think this lesson, I'm just going to say about these, like how you can find out all of these, that if you want to continue on like fifth derivative, sixth derivative, well, you can try them on your own. But in this lesson, I'll just end here right now. So if you like our videos, don't forget to subscribe to our channel. And thank you for your watching.